Another type which is most commonly used in oil and gas industry is the one what we are seeing over here, which is S type of floating head. It is also called as a immersed type of floating head. Why it is called as a immersed? Because unlike the outside packed what we have seen, it is not having any direct contact with the shell side. It will be having a tube sheet which is called as a floating tube sheet. It will be having its own head which is called as a floating head. This portion, the floating head along with the flange will be there. Then there is again there will be a split ring which will be placed on another side of this tube sheet, against which the nut and the stud assembly will be getting tightened. So this tube sheet will be having a gasket in between this head and the tube sheet. That gasket will be getting compressed. So this represents your tube side. As you can see over here, the outlet has been taken from the other side. This is possible only when there is an odd number of passes. But most commonly, to avoid a sealing arrangement over here, this floating head will always come into 4, 6, 8 passes. So there will not be any nozzle to be taken out from this head. So all the nozzles will be on the stationary sides. So there will not be any problem. But if you want to have odd number of passes, then there has to be a sealing arrangement provided at this junction. But it is uncommon. This is not been commonly used. So this disc end will be closed like this. This disc end will be closed like this. So this is called as a head. This is the type of head. If we go to 1-6 of ASME, then this 1-6 will represent this type of heads, where the disc end and flange represents a single element, or they will behave like a single assembly. So how this will look like? So let's have a look at over here. So these are the tubes. This green one is the tube sheet. This green one along with this flange represents the floating head. This blue color one is representing the split ring. This represents the split ring. How this assembly will work, that is also we are going to see in 3D animation. So how this we have already seen it in detail video of this AES type of floating head construction, that this tube sheet will be having outside diameter lesser than the shell ID, that is main shell ID. So and the main shell is provided with the flange joint over here. So one flange will be having the ID equal to the shell ID, and another flange will be having an ID which is more than this shell ID. Why so? Because it has to incorporate or accommodate this floating head and this split ring. These are bolted construction, so it will be having the PCD OD of this flanges, so it will be much more than this tube sheet OD. So to incorporate that, this side of the shell side flange will be having higher diameter than this side, and this side of this cover, which is shell side cover, we can say, because the fluid will be all around this. The shell side fluid will be all around this, and this floating head will be totally immersed inside shell side fluid. Hence, it is also called as immersed type of floating head. One more immersed type of floating head is there, which is called as a T construction. This is floating head with backing device. Backing device. Why this backing device is provided? Let's understand that. So once the tube sheet along with the tube bundle is inserted inside the shell, it will come from here and it will come till this point. Now this bonnet is not there. Imagine this bonnet is been removed. It is untied from here and it will be removed. So what is happening? This side there is an open access. So from this side what you can have, you can easily have this floating head coming in, which is going to sit, or it is going to fit with this tube sheet. This split ring comes in two halves, one from upper side, one from lower side, and it is going to fix at the back end of this tube sheet. Why it cannot slide from right side? Because if we have just notice over here, the tube sheet is having OD which is more than the ID of this flange. So this ID will not allow it to slide from this side. And that's the constructional requirement, that you have to split it in at least two halves. So one is come from top, another is coming from down, and then it is going to move and it is going to lock with this tube sheet. And this head can come from right side, and then the bolting will be done. Here will be the gasket joint. So this floating head, split ring and tube sheet will represent the floating arrangement. And after that, this shell side cover will be coming in and it is going to fix it over here. So whenever there is a high temperature difference, thermal expansion will be there. Because of pressure, there is a movement of this entire assembly towards right side. So this entire assembly is going to move on the right side. This entire assembly is going to move on the right side and come again its original position, depends upon the temperature difference. So it is not getting attached by any means to the shell side. So it is completely free. It is completely free. There is a gap between the outside dimensions of this split ring or this head flange and the shell side cover shell, main shell, or we can say the main shell cover. So there is a gap in between this. So it is easily going to be float inside the fluid, and it is going to be slide towards right, depends upon the temperature difference. So this is how the assembly will look like. This is called as a floating head with backing device. And as unlike the other T type of construction, here the tube sheet OD is having less than the shell ID, and here there is no and here there is a higher diameter of the flange provided on the shell side to incorporate for this arrangement. So this tube sheet face, which is very close to the outside tube limit, that is called as the OTL, where the maximum tubes are or the outermost tubes are encircled. From that, this OD is very near, unlike the T type of construction. Because in T type of construction, we are going to see in detail how the construction will look like. So this is S type of construction. This is S type of construction. So let's have a look at how it will look like in 3D animation. So we have removed the shell side. We have removed the shell side assembly, right? Now we have to look at the floating head arrangement. This is the split ring, the blue one. This light blue one represents the floating head. So let's have a look at. So this represents the tube sheet. This is floating head. This is split ring. How this split ring differs? Let's have a look at. It is going to be get splitted in two halves like this. It is going to be splitted in two halves. Why it is getting splitted? Because it is having an ID which is less than the tube sheet OD. So let's have a look at the construction. So this ID is lesser than this tube OD. So that's the reason why it cannot slide from this side or this side and get on the other side. Since it is having lesser diameter, so it has to be made in two halves, and the two halves will come and then they are going to engage with this arrangement provided over here with the tube sheet like this. It is going to get fixed. So this split ring is fixed with the tube sheet. Here comes the gasket which is going to fit over here. So now we can have a look. The gasket will come and sit over there like this. This is the floating head along with the pass partition plate. So that is going to be placed over here, and then the bolting will happen for that floating head. And when we are going to tight the bolts, the gasket will be compressed. So that represents your floating head assembly. It comprises of this tube sheet, split ring, and floating head and gasket along with the tubes. And after that, the shell will be inserted, and from other side the shell cover will be inserted, which will be having the higher diameter than the OD of these head flange and the split ring flange. So that backing device is provided. That's the reason it is also called as a floating head with backing device. That split ring is act as a backing device. There is no gasket on the split ring side. It is just going to get engaged inside that groove. So let's have a look at one more time the assembly. So floating head, tube sheet, gasket, and this is split ring. So for better understanding, you can have a view at our floating head animation, what has been covered in first lecture, lecture 1-2. So there this entire assembly has been Very neatly explained. So this represents a rare end type of bonnet, which is called as a S type of construction, which is floating head with backing device.